How you doing, my 7th grade advanced class? Let's go ahead and go over 8-1. Says sketching a graph that represents a situation. Well, a trading card becomes more valuable over time. The value increases at a constant rate and then at a faster rate and faster rate, which tells me um, that it's going to go up and then the slope is going to curve up higher and higher and higher. That's exactly what we're getting. It's going up and it curves higher and higher and higher. Number 3 says you jog at a constant rate, you stop for a break, and then walk at a constant rate again. If I'm walking at a constant rate, I would think that I would be walking, right? Have be a straight line. Then if I stop for a break, I'd be making no progress. And then I would start up again. I think that's the way it would have to look. Oh, there we go. Starting off, and then we come back down, right? This is time, this is speed. So we're at a certain speed, and then we stop altogether, right? We have no speed at all. And I'll be honest with you, I'm not sure I would have put this line here, because this indicates at this moment that I'm going all these speeds. I think I just would have put a line here, and I would have put a line here, and I would have put a line here. I'm not sure I agree with having this the way it is right here. Because it portrays that at this time, I'm going all these different speeds at the same time, and that's impossible. So I'm going to let the book have its little graph there, but I think we can all agree for this to be accurate, the line going up and down should not be there. All right, number 5, determine whether the side lengths form a triangle. Got 9 meters, 24, and 13 meters. I'm going to regress to the rule that says my 2 smaller sides have to be bigger than my third side. So 9 and 13 make 22, and 22 is not bigger than 24. No, this cannot make a triangle. 9 plus 13 is less than 24. All right, we're going to go on to number 7. To do number 7, we're going over here to the smartboard. I'm going to get my pin out here, and actually, let me see what it says first. Finding the product of powers. Write the expression in repeated decimal form, then write the expression as a power. If I'm writing 5 to the 6th power plus 5 times 5 to the 3rd power, this is really, and I think I'm just going to write this really small here, this is really going to give me 5 times 5 times 5 times 5. We have to do this 9 times, right? So 5 more times. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8. I guess one more makes 9. Okay, that's what it would be as repeated, but as a say an expression of power, I would just say that's 5 to the 9th power. Make sure I wrote this right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 5 to the 9th power. Let's go to number 9 now. This is q to the 3rd power times q to the 4th power. I'm going to go back right over here and say this is really q times itself 7 times. So I've got q times q times q times q times q times q times, and I believe that's 1, 2, 3, 4, 5, 6, 7 times. Or I could simply write q to the 7th power. Now we got number 11 here. Writing expressions using exponents. Write the product using exponents. So if I'm writing this using exponents, I see I got negative 4 times itself 3 times. So that's going to be negative 4 to the 3rd power. And notice I don't put negative 4 without the parentheses, because then that would mean the 3 was just on the 4 and not on the negative, and that's not the case here. And then I'd have y to the 2nd power, because there's only 2 of those. Number 13, I have negative t twice, so that's going to be negative t to the 2nd power, and then m to the 3rd power, because there's 3 of them. 15 would be, now this time the negative's outside of it, so I'm going to put negative and in parentheses 1/4. And this is going to be 1, 2, 3, 4 of them, so the fourth power. And notice I don't just put 1/4 to the fourth power, because if I did, that 4 would only be applied to the 1, not the 4. But the parentheses makes it to all of it. So that's why it's important to remember you need the parentheses there. Then s to the 1, 2, 3, 4 power as well. All right, let's go to number 17. Evaluate the expression. If I'm evaluating this, I'm finding what it equals. This is negative 1.5 to the third power. I know negative 1.5 to the third power is negative 1.5 times itself 3 times. So I'm going to bring my calculator up here and make this really easy. Wow, that did not work out well, sorry. Try this again. Calculator, sorry. And I can see right here it says negative 1.5 to the third power. So in parentheses, I'm going to put negative 1.5. And it looks like it put 1.5 without it. I'm going to try it afterwards now, since that didn't work. Let me try deleting this and then try putting parentheses 1.5 negative. Let's see if that helps. There we go. And then I'm going to put it to the third power, which means I'm going to click on this one here, put it to the third power. This is how you'd work your calculator. And that's going to give me negative 3.375. Negative 3.375. Next, we're going to number 19. Number 19 says 0.9 to the fourth power. Once again, I'm going to bring up my calculator here. I'm going to bring up 0.9. And I'm going to put it to, use this again, and then put it, that little arrow there means it's to the whatever power I hit next, which is to the fourth power. That's going to equal 0.65, 0.6561. 0.6561. Next, I'm going to go to number 21. Number 21 says 2.4 to the fifth power. So once again, I'm going to clear my calculator and put 2.4 and put it up here to the fifth power. And that's going to give us 79, well, that's a big number, 79.62624. 79.62624. And I'm going to double check that now. 79.62624. All right. Let's go to number 23 next. All right. 23 says a mason builds a square brick patio. So square is the shape we're looking at. That means all sides are the same. That is 13.5 feet by 13.5 feet. Write and evaluate the expression to find the area. The area is length times width. So that's a pretty easy one to do. I'm going to take, well, this is really 13.5 to the second power. So 13.5. And I'm going to use my arrow here. And I'm going to put it to, actually, I could have just squared it up here. Let me try doing that so you can get an idea of how that button works. 13.5. All right, and then I'm just going to put the square button here. That's 182.25. So 182.25, and that would be feet squared. All right, we're on number 25 now. Simplify the expression, write your answer as a power. Well, m to the 10 times m to the 6 is m to the 16. When I'm multiplying two bases that are the same, I can add right? I can add my exponents. Number 27, when I have a power to a power, and that's what this is here, I can multiply them. So this is going to be negative t in parentheses here to the 12th power. 29, we're multiplying, again, the base is the same, so I simply keep the base the same and add the exponents. 4 plus 2 is 6. Number 31, jk is being multiplied to itself, and the powers are 2 and 6, so I would put this as jk to the 8th power. All right, number 33 is next. Again, if I have a power to a power, I multiply them together, so this should be n to the 15th power. And number 35, I see that I have negative 5 over 7 as the base. Since I'm multiplying it, I can put negative 5 over 7. And then put that to the, well, that'd be 17th power. All right, let's move on. Number 37 is next. Simplify the expression. Simplifying means I've got to go ahead and write everything as an evaluation. I got 6 to the 3rd power, and then g to the 3rd power. I already know that g is going to be the 3rd power, but now I got to find out what 6 to the 3rd power is. Well, I know 6 times 6 is 36, but I don't know what 36 times 6 is. So I'm going to put 6 to the power of 3, 216. So this would be 216 to the g to the 3rd power, 39. I got 1 to the 5th power, and then I got k. So this 1 is going to get multiplied all of the 2nd power. So 1 over 5, I shouldn't say 1 to the 5th power, 1 over 5 k to the 2nd power. So 1 is going to get times 1. 1 times 1 is 1. 5 times 5 is 25. And k times 2 is k to the 2nd power. All right. 41. I got r and t to the 12th power. That's going to give me r to the 12th power and t to the 12th power. Very simply. All right. Let's go ahead and go to number 43. Which expression is equivalent to negative 5.3p for y to the 2nd power? Wow. So instantly I got to figure out what is, let's see, this could be, yeah, I have to take this 2, multiply it to 5.3, negative 5.3 to find out what that number is. So I'm going to try that first. I would not make the mistake of taking 2 and adding it to 4. This is definitely wrong over here. So I'm going to take a negative. First, I got to put 5.3 and then make it negative, right? And I really should have, I guess, no, I can multiply that to itself. I'm going to make this easier on myself. Put a parenthesis here. Why is that? I'm not quite sure why this is coming up to the 3rd power here. I'm going to X out of this and go back into my calculator and hoping it resets. That's better. So I'll put this here and I'm going to put 5.3, make it negative, and close the parentheses and then put it to the 2nd power. And that gives me 28.09, which tells me it's either going to be A or it's going to be D. Now I have to go ahead and make sure that, well, I don't really have to do anything. Look, P is 8th power, and then Y is the 2nd power. Both of these have the same power to both of those, and they're correct, because 4 times 2 is 8, and 2 times 1 is 2. But is this going to be a negative or positive? Remember, negative times a negative, and that negative is here. We are going to multiply it to itself. It's going to be a positive. D has to be the right answer. D is the answer. 44 is for you to do, and I think that was the last one. So I'm done with mine. Good luck with yours, and I'll see you in class for grade.